Hello ma'am, I am Mohammad Riazuddin from Institute of Aeronautical Engineering, bearing roll number 20955A04008 from ECEB section, and my AAT Tech Talk topic is RC phase shift oscillator. Before going to the topic, we'll see what is an oscillator. An oscillator is a circuit which produces a continuous, repeated, alternating waveform without any input. Oscillators basically convert unidirectional current flow from a DC source into an alternating waveform which is of the desired frequency as decided by its circuit components. Its principle Its working principle is nothing but the basic principle behind the working of oscillators can be understood by analyzing the behavior of an LC tank circuit shown in below, okay, which employs an inductor L and a completely pre-charged capacitor C as its components. Here, at first, the capacitor starts to discharge via the inductor, which results in the conversion of its electrical energy into the electromagnetic field, which can be stored in the inductor. Once the capacitor charges completely, there will be no current flow in the circuit. This is nothing but working principle of an oscillator. Here, the block diagram shows the oscillator. There is nothing but amplifier with a with a feedback connected, output connected to input with a feedback. Coming to RC phase shift oscillator. RC phase shift oscillator uses a resistor capacitor RC network to provide the phase shift required by the feedback signal. They have excellent frequency stability and can yield a pure sine wave for a wide range of loads. See the in block diagram, in here is the input, capacitor, resistor, output. This is nothing but RC network. Ideally, a simple RC network is expected to have an output which leads the input by 90 degrees. However, in reality, the phase difference will be less than this as the capacitor used in the circuit cannot be ideal. Mathematically, phase angle of an RC network can be expressed as tan inverse of XC by R, where XC is nothing but 1 by 2 pi FC is the reactance of the capacitor C and R is the resistor. In oscillators, these kind of RC phase shift networks, each offering a definite phase shift, can be cascaded so as to satisfy the phase shift condition led by the Barkhausen criterion. Coming to the RC phase shift oscillator is formed by cascading three RC phase shift networks, each offering a phase shift of 60 degrees. Here we have RC network, here we have RC network, here we have RC. This is nothing but three RC networks. And then here the collector resistor RC limits the collector current of the transistor resistors R1 and R from the voltage divider network, while the emitter resistor RE improves the stability. Next, the capacitor C and C out are the emitter bypass capacitors and the output DC decoupling capacitor respectively. Further, the circuit also shows three RC networks employed in the feedback path. This arrangement causes the output waveform to shift by 180 degrees during its course of travel from output terminal to the base of the transistor. Here, this makes the net phase difference to be 360 degrees, satisfying the phase difference condition. One more way of satisfying the phase difference condition is to use four RC networks, each offering a phase shift of 45 degrees. Hence, it can be concluded that The RC phase shift oscillators can be designed in many ways, as the number of RC networks in them is not fixed. However, it is to be noted that although an increase in the number of stages increases the frequency stability of the circuit, it also adversely affects the output frequency of the oscillator due to the loading effect. The generalized expression for the frequency of oscillations produced by a RC phase shift oscillator is given by f is equal to 1 by 2 pi RC root of 2n. N is nothing but number of RC networks. Thank you.